Good day. In this video, we will be looking at 2017's NSC November paper 2, and we're looking at question 1, data handling. So given to us here is a table, and in the table shows the time in seconds rounded to one decimal place taken by 12 athletes to run 100-meter sprint, and the distance in meters rounded to one decimal place of their best long jump. So generally that will be your X, the top row, and then your bottom row will be your Y. And this scatter plot is a representation of that data, and we can see the line and all the points in proximity to the line itself. Okay, so the instruction here is that the equation of the least squares regression line is y hat equal a plus b times x. So we need to find the value of a and b, and we do that by using our Casio calculator. So let's have a look at how we do that. So your data, you need to have your data in front of you, obviously, and we are going to use our calculator. And the first thing we are going to do is to put our calculator in stats mode. Press mode, and then you will select number 2 because 2 corresponds with stats, and that's what we want. So now that we have our stats mode, we select mode, then we click on number 2, which is stat, and then keep in mind our formula is y equal a plus b times x. So that's number 2 there again. So I press number 2, and then I'm going to have an x and y column where I'm going to put in my x and y values. And if I look at my table, all these values here on top, that's going to be my x values, and all these values at the bottom, that's going to be my y value. So you will enter all this into your calculator. Let me remind you how to do that. So your first value is 10.1. You press enter 10.1, and then you press equal, and then that value will be saved as your first x value. Okay, and then the second value is 10.2. You press equal, and then that value will be saved as your second value. Okay, and then you can continue to complete all your values for your x. So once you have entered all your values, we'll now see there are 12 values. You then use your cursor and you move across to your y value, and then obviously you press down, and when you press down, then it will place you in the first position for your y value, and your first y value is 8. So you press 8, and then you say equal, and then 8 will appear, and then you enter 7.7, you press equal, and then that will appear, and then you continue to enter all these values. And once you've entered all your data correctly, you will notice that you have the same number of values on both sides. Please make sure that that's the case in order to ensure that you have entered your values correctly. The next thing you do is you press AC. Don't worry, your data will not be lost, it's stored. And then you press shift, and then you press number 1 because you want to go to the stat, and then you're going to get these options. Now we would like to look at the regression line formula. The REG is an abbreviation for that. So we press 5, and now I'm able to get all my values. I can get A, I can get my correlation coefficient, and I can get my B value as. So we want A and B's values. So we want number 1, which is A, and number 2, which is B. And then for our B value, we do the same. We press shift, we press stat, we press number 5, and then we select number 2. That's going to give us our B value, more or less minus 0.64. Okay, and then 2 marks will be allocated there, 1 mark will be allocated there, and then that will give you 3 marks for question 1.1. So the next question is for us to determine the following. An athlete runs the 100-meter sprint in 11.7 seconds. Use the formula to predict the distance of the best long jump of this athlete. So all we do is, remember, if you look at your table, the sprint time are x values. And if you look at this question, it's again the sprint time of an athlete. So again, that 11.7 is going to be an x value. So what we then do is we take that 11.7, because remember it's an x value, and we substitute into our formula, and you put this into your calculator, and your calculator answer for this should be more or less 6.85. Okay, and that's 2 marks there. So it's going to be 1 for the correct substitution, and obviously 1 for the answer. So that's how you are going to score your 2 marks there. Let's have a look at the next question. Another athlete completes the 100-meter sprint in 11.3 seconds, and the distance of his best long jump is 7.6 meters. If this is included in the data, will the gradient of the least square regression line increase or decrease? Motivate your answer without any further calculations. So when they say without calculations, then it means you must just use your words. So if you look at the data given, so our highest is 12.5 at 6.4 for that. Now if you look at the point, remember that's an x and a y value, so that becomes a point on your scatter plot. So if you take this as a point, 12.3 and 7.6, and you plot this on your graph, you will notice that 12.6 will be slightly above there, more or less, okay, and that gradient 7.6 is going to be there. So this is more or less where that point will lie. So how do I conclude this? The point 12.3 in 7.6 lies above the current data. And that is what you should say there. It lies above the current data. So now that we understand that that point lies above the current data, let's go back to 1.3. Another athlete completes the 100 meter sprint in 12.3 seconds. And the distance of his best long jump is 7.6 meters. If this data is included, will the gradient of the least square regression line increase or decrease? The gradient will increase. Why? Because it lies above the current data. And that's exactly what you write here. You write here, the gradient increases. That's your answer. So your gradient increases. Why? Because it lies above the current data. And that's it for 1.3.